Hello there, and welcome to the Sleepy Astronaut channel. I'm so glad you found your way here tonight. Maybe you're settling down after a long day, or perhaps you simply enjoy drifting to sleep with gentle wonder, letting thoughts of distant skies replace the busy noise of everyday life. There's nothing you need to do now but rest. Let your breathing soften, your body loosen, and your mind settle like calm starlight on quiet water. Because tonight, we're taking a peaceful journey into the world of rocket spaceships. The vessels that help us slip the bonds of Earth and wander the velvet dark between the stars. From the earliest dreams of flight, to the towering engines that roar us into orbit, to the quiet, hopeful futures of interstellar travel. We will explore it all, slowly and gently. And if these explorations help you rest, consider liking the video and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes, let your thoughts soften, and let's begin. Fact 1. The dream of leaving Earth. Long before rockets ever touched the sky, humanity carried the dream of flight quietly in its heart. People would look up from fields, from city streets, from mountain valleys, and feel something gentle pull inside them. A curiosity, a longing, a whisper that said, "What if we could go there?" To the moon, silvering the night, to the distant stars that glowed like scattered embers across deep velvet. It wasn't urgency, it was wonder. The slow question of a species learning to imagine. Over thousands of years, we watched birds, clouds, comets, and auroras tracing the sky like a story we couldn't yet read. And though we didn't know how to reach it, we knew it mattered. This was the beginning, not of machinery, but of dreaming softly upward. Beyond this dream, something ancient awaited discovery. Fact 2. Fire as the first engine. The first rockets were not made for space, nor even for travel, but for curiosity about flame. Ancient peoples learned to trap fire inside hollow tubes, mixing powders that burned with sudden breath. When these mixtures ignited, they didn't just burn, they pushed. A small tube would leap forward, as if trying to break free. This simple motion held the secret of every spacecraft to come. That fire, when guided, can move us. Fire was not only warmth or danger, it became direction, a whisper of propulsion. Early rockets were simple, rough, unpolished. They cracked the air with sparks and smoke, but they taught us that motion does not need wings. It needs reaction. The universe answers force with its own return. And slowly, we began to learn that pushing against nothing can still move us forward. Fact 3. Ancient Chinese fire arrows. Around the 13th century, in ancient China, the first true rocket-like devices appeared as fire arrows. They were small wooden shafts, fitted with tubes of burning powder, hissing and sparkling as they flew. Though created for war, their flight told a gentler story. The story of controlled flame, of fuel carrying its own oxygen, of motion that did not rely on wind or weather. These arrows soared because they brought everything they needed within themselves. That idea would one day carry astronauts beyond Earth's sky. But for now, the arrows simply traced streaks of orange light across night air, bright and brief like shooting stars born from human hands. People watched them rise and felt something wordless stir, an early echo of spaceflight's promise. From these glowing trails, our journey upward slowly continued. Fact 4. The whisper of gunpowder flight. As people refined the powders that fueled early rockets, they discovered something gentle hidden inside the roar. The mixture of charcoal, sulfur, and saltpeter did not just burn. It released a steady breath of expanding gas. That breath became motion, a quiet push through the air. In those days, rockets did not soar high. They arced in short, bright paths, trailing sparks like slow-moving meteors. Yet each launch taught an important lesson. That movement begins with release. By shaping the tube, thickening the walls, and adjusting the grain of the powder, ancient makers could influence how smoothly the flame unfolded. It was not noise they sought, but control, a measured whisper of fire. These early flights were small, and they faded quickly, but every flicker carried the promise of leaving Earth behind. The dream deepened, and minds began to wonder further. Fact 5. Early visionaries of the sky centuries passed before anyone imagined rockets not just as tools of war, but as vessels for exploration. Poets, philosophers, and storytellers were the first to lift rockets from the ground into the heavens, not with engineering, but with imagination. They told of chariots of flame, silver ships pulled by swans, travelers who rode to the moon in bubbles of light. These tales, though impossible at the time, gently encouraged humanity to think upward. Sometimes, it is imagination that moves first, long before metal or fuel or equations. The visionaries didn't know how rockets could reach the stars. They simply believed that perhaps one day they could. And that belief was enough to carry us across centuries. Because before you build a ship, you must know where you wish to go. Fact 6. Konstantin Tsiolkovsky's quiet equations. In the late 1800s, a quiet Russian schoolteacher named Konstantin Tsiolkovsky sat alone beneath the night sky and asked a simple, beautiful question. How could a rocket escape Earth's gravity? He didn't have laboratories or engines, only a deep patience for thought. From his desk, he worked out the mathematics of spaceflight, how fuel, mass, and speed relate, how a rocket could accelerate through the vacuum, how stages could help it climb. These equations became the foundation of rocketry. Tsiolkovsky believed that Earth was humanity's cradle, a place of beginning, not the final home. His work moved slowly, like a quiet tide of understanding washing across the world. Few noticed at first, but those who did felt something momentous stirring. The dream was no longer myth. It had found its roadmap. Fact 7. The idea of escape velocity. To leave Earth, a rocket must rise faster than gravity can pull it back. This speed is called escape velocity, about 11 kilometers per second. It sounds fierce, but the idea behind it is quiet and elegant. Gravity is like a hand resting gently on your shoulder, reminding you that Earth is home. To slip from that hand, a rocket doesn't need to fight in anger. It simply needs steady, continuous push, momentum gathering like a slow sunrise. Once reached, the pull of Earth softens and the rocket drifts into a wider sky. Escape velocity isn't a battle. It is a gentle release, the soft moment when upward longing becomes motion. And so we learned what it takes to leave the cradle of our world. Fact 8. Gravity as a gentle anchor. We often think of gravity as something heavy, something that holds us down. But in truth, it is a quiet companion, the invisible thread that keeps oceans from drifting into the sky, that guides moons in their slow, silver paths, that gives our steps meaning. For rockets, gravity is not an enemy. It is a reference point, a reminder of where the journey begins. The rocket rises not in defiance, but in transition, trading one kind of home for another. Even astronauts speak of gravity fondly when they return, how it cradles the body, how it feels like being welcomed back. Gravity does not vanish in space. It simply spreads out thinner, like a whisper becoming an echo. To understand rockets, we must understand the embrace they are leaving. Fact 9. Building a ship that can break free. A rocket must be strong enough to hold its fuel, light enough to rise, and shaped to slip through air without waste. Engineers learn to think of rockets like delicate shells, thin, resilient, carefully balanced. Much of a rocket is not cargo nor crew, but fuel. Fuel to lift itself, fuel to lift the fuel, fuel to lift the memory of flame. Every gram matters. Every bolt and panel is chosen, like a note in a quiet song. When the engines fire, the rocket does not leap instantly. It leans into the sky, pushed upward by columns of flame shaped with precision. The design is not brute force. It is poetry in metal, patience in pressure. With understanding, the journey upward continues, one quiet breakthrough at a time. Fact 10. The shape that slices the air. A rocket's shape is tall, smooth, and narrow for a gentle reason. It must slide through the atmosphere with as little resistance as possible. Air, though invisible, has texture, a quiet, ever-present pressure that presses back against anything moving through it. Engineers sculpt rockets the way rivers sculpt stones, slowly, thoughtfully, seeking smooth lines where the wind can drift past without struggle. The pointed nose softens the push of air, while the long body lets the rocket rise without tumbling. Beneath the simplicity is careful balance, like a dancer leaning just enough to stay upright. The rocket is not shaped only for power, but for grace, for the calm, elegant ascent from ground to sky. And with this shape, the journey upward becomes possible. Fact 11. The strength. Beneath the shell. Despite their size, rockets are surprisingly thin-skinned. Their metal shells are often only a few millimeters thick, light enough to fly, yet strong enough to contain vast oceans of fuel. This delicate balance is one of the quiet triumphs of engineering. Inside, the tanks hold liquids colder than winter stars, and they must stay still even as fire roars below. The rocket's body flexes slightly as it rises, adjusting to shifting forces, like a tree bending in wind. Strength is not always heavy. Sometimes it is patient, resilient, gracefully designed to withstand motion. To touch a rocket is to realize that power does not require mass, only intention, alignment, and care. Within this slender form lies the ability to leave a world behind. Fact 12. Chambers of controlled fire. At the heart of every rocket is the combustion chamber, where fuel and oxidizer meet in a bright, roaring exchange. But this fire is not wild. It is contained, guided, softened by precision. The chamber must survive temperatures that would melt most metals, yet hold steady moment after moment as pressure builds and releases into thrust. Think of it like a furnace that breathes, not chaotically, but rhythmically, a steady heartbeat of flame. Engineers cool the chamber from within, letting cold fuel flow through tiny channels along its walls, protecting it while feeding the fire it births. This is where the journey begins, in the quiet miracle of controlled flame. From this steady burn, the rocket rises, patient and sure. Fact 13. The quiet logic of fuel and oxidizer. On Earth, fire breathes oxygen from the air, but in the silence of space, there is no air at all. So rockets must carry not only their fuel, but also the oxygen needed to burn it. This pairing is called fuel and oxidizer, and together they form the heart of propulsion. Some fuels are soft and shimmering liquids like kerosene. Others are cryogenic, so cold that they fog and whisper when touched by warmer air. The oxidizer is often liquid oxygen, pale and ghost-like drifting in chilled tanks. When the two meet inside the engine, they ignite into a bright, controlled bloom of flame. It is a meeting of elements, a conversation between heat and pressure. And from that conversation, the rocket finds its voice to rise. Fact 14. The spark that begins the journey. Every launch begins with a single spark, a quiet flicker that awakens the engine. This spark can come from an electrical ignition, a small flame, or even a chemical reaction that starts instantly when the fuel and oxidizer touch. The engine does not roar all at once. It swells slowly, like breath being drawn before a long note is sung. The rocket trembles gently, as if gathering courage. Smoke curls around its base, drifting through morning air. Then, when the thrust becomes greater than the weight holding it to Earth, the rocket begins to rise. Not in a leap, but a smooth, deliberate lift, like a hand releasing something it once held close. The moment of liftoff is quiet wonder turning into motion. Fact 15. Thrust, a push, through nothing. In space, there is no air to push against, yet rockets move forward all the same. They do so through thrust, the steady stream of hot gas pushed out from the engine's nozzle. According to Newton's third law, every action has an equal and opposite reaction. So when the gas is pushed downward, the rocket is gently, insistently pushed upward. It is a simple idea, but in practice, it becomes poetry. The rocket glides through a vacuum where sound cannot travel, where fire burns without flicker, where motion is pure and uninterrupted. Thrust is not noisy in space. It is silent, steady, like a whisper moving through eternity. With thrust, the rocket leaves the familiar world and enters the endless dark. Fact 16. Newton's third law, thoughtfully understood. The foundation of rocket flight rests on a simple truth described by Isaac Newton. For every action, there is an equal and opposite reaction. It is a gentle law, not loud or forceful, but steady and dependable. A rule that shapes worlds and holds galaxies in their dance. When a rocket expels gas downward through its engine, the rocket itself is pushed upward. This relationship is not a struggle, but a harmony, a trait of motion, a balanced conversation between direction and force. Even in deep space, where there is no ground, no air, no sky to press against, this law remains. The rocket moves forward because it lets go, releasing energy in one direction to drift in another. Flight is born from this quiet exchange of forces. Fact 17. The long, tall structure of rockets. Rockets may seem enormous, towering above launch pads like silver spires, yet most of their height is simply fuel. Tank after tank rises into the sky, full of chilled liquids waiting for their moment of ignition. The rocket's body is like a column of breath, a tall vessel designed to carry flame upward. Inside, there are no large rooms, no empty halls, only carefully arranged machinery, thin metal walls, and the pathways that guide fuel to engines. Everything is tuned to be light, to carry only what is needed, to lift rather than weigh down. From a distance, rockets appear solid and strong. Up close, they are surprisingly delicate, shaped by precision rather than mass. Their height is not for grandeur, but for the journey they must make. Fact 18. Staging. Letting go to climb higher. To reach space, a rocket must become lighter as it climbs. ITAR cannot carry empty tanks or unneeded mass. So rockets are built in stages, stacked sections, each with its own fuel and engines. When a stage finishes its work, it separates softly and falls away, returning to Earth or drifting into the sea. What remains continues upward, freer, lighter, closer to the stars. Staging is a lesson written into rocket flight. To go farther, one must release what is no longer necessary. There is a quiet poetry in it. The idea that progress is sometimes achieved not by holding on, but by letting go. And with each release, the rocket rises toward a wider sky. Fact 19. Guidance computers that think softly. A rocket may appear to move with raw power alone, but within it lives something gentle, a guidance system that quietly calculates every moment of flight. These computers do not shout instructions, they whisper them, adjusting angles and thrust by tiny degrees. Even a fraction of a degree matters when traveling to space. A small tilt on Earth can become hundreds of miles of difference in orbit. So the guidance system watches carefully, sensing motion, vibration, and drift, then correcting it with soft, precise changes. It is the steady hand behind the flame. The rocket does not simply fly. It is guided, accompanied, and cared for by an intelligence shaped to be calm under pressure. With guidance, the journey remains true, even in the vastness above. Fact 20. Steering flame itself. To change direction, a rocket cannot use wings the way airplanes do. There is no air in space to lift against. Instead, rockets steer by directing the very flame that pushes them forward. This is called gimbaling. The gentle pivot of the engine, so the stream of fire points slightly to one side. The rocket responds in turn, rotating, gliding, aligning itself with the path ahead. Imagine holding a garden hose. When you shift the direction of the water, your hand feels the push. Rockets move in a similar way, but on a scale of stars and silence. Steering is not abrupt. It is subtle, continuous, like guiding a boat across calm water. By shaping fire, the rocket shapes its journey through the dark. Fact 21. The humbling weight of payload. Every rocket carries something precious, a payload. It may be a satellite, a telescope, a crew capsule filled with dreams and heartbeats, or instruments meant to explore unknown worlds. Compared to the towering rocket itself, the payload is remarkably small. Most of the rocket exists simply to lift this tiny, meaningful cargo into space. It is a reminder that greatness is not always measured in size, but in purpose. The payload rests beneath a protective shell called a fairing, shielded from wind, heat, and vibration until the moment it reaches the quiet above the atmosphere. When the fairing opens, it is like a flower slowly unfolding, revealing what the entire journey was for. And gently, the payload continues where the rocket cannot. Fact 22. The fairing that protects. Delicate dreams. At the very top of the rocket sits the payload fairing, a smooth shell that protects whatever precious cargo the rocket carries. Inside may be satellites, telescopes, experiments, or a small capsule meant for human hands and hearts. The journey from ground to space is turbulent. Air rushes, the rocket shakes, sound rolls through the structure like distant thunder. The fairing shields the payload from all of this, cradling it gently, like a cocoon. As the rocket climbs higher and the air grows thin and quiet, the fairing is no longer needed. And so, in a slow, graceful motion, it separates and falls away, drifting back toward Earth. What remains continues upward, finally touching the silence it was built for. Fact 23. The moment of liftoff. There is a soft stillness just before a rocket leaves the ground, a pause filled with held breath and waiting air. Then the engines ignite, not as a sudden burst, but as a growing column of light and sound. The rocket begins to rise slowly, almost reluctantly, as if Earth is letting go one careful inch at a time. People watching often describe this moment not as loud, but as awe-filled. A deep hum felt in the bones rather than heard with the ears. The rocket does not leap. It ascends, steady and deliberate, guided by invisible forces and precise calculations. In that rising, the boundary between Earth and sky softly begins to blur. Fact 24. Vibrations like rolling thunder. As the rocket climbs, the world beneath it shakes. The engines produce vibrations that ripple outward through the air and into the ground. A long rolling thunder that can be felt miles away. Yet, inside the rocket, astronauts describe the sensation differently. It is not frightening, but rhythmic, a strong, undeniable presence of power. The spacecraft vibrates, hums, and sways, but always with purpose, always guided. These vibrations are the song of ignition, the music of flight, the physical reminder that thousands of parts are working together as one. The entire vehicle becomes a single organism in motion. And through this deep trembling, the rocket climbs closer to the quiet above the clouds. Fact 25. The color of rocket flames. When a rocket rises, its flames are not always the same color. The flame's hue depends on the fuel. Liquid oxygen and hydrogen burn in a pale, almost invisible blue, while kerosene glows in bright gold and orange, and solid boosters blaze in fierce white, like a sunrise condensed into fire. To the eye, these colors seem like pure heat, but they are also chemistry in motion, molecules breaking and joining again in a dance of light. Observers watching a launch at dawn can see the plumes stretch and curl, a luminous cloud suspended in deep morning quiet. Though the engines are powerful, the flame itself seems soft from a distance, a brushstroke of light beneath the rising ship. Each color is a signature, a gentle reminder of the fuel that carries us upward. Fact 26. Breaking the sound barrier. As the rocket climbs higher and accelerates, it reaches a moment called max Q, the point of maximum aerodynamic pressure. Here, the rocket pushes hardest against the thickest layers of air, and the sound barrier trembles before it. Yet the moment itself is quick and almost silent to those on board. There is no loud crack, no shudder of catastrophe, just a steady increase in vibration, and then a release. The air thins, the resistance fades. The rocket continues, now moving faster than sound itself, leaving behind a sky rippled briefly by its passage. From the ground, the shock wave might arrive moments later, a deep, distant boom echoing like weather rolling across plains. But the rocket, already higher, already quieter, moves gracefully into the calmer air above. Speed becomes silence. Fact 27. The sky, turning from blue to black. As the rocket rises, the sky slowly changes. The familiar blue begins to fade, not suddenly, but gradually, like watercolor being gently diluted. The higher you climb, the fewer air molecules remain to scatter sunlight, and the blue becomes thinner, fainter, softer. Soon, the sky turns a deep navy, a twilight that never truly ends, and then, just a little higher, black. But this black is not empty. It is filled with stars that no longer twinkle, sharp and still against infinite darkness. Astronauts often say, this is the moment everything becomes quiet inside, when the world below looks small, peaceful, wrapped in its blue atmosphere like a sleeping child under a blanket of air. The journey has reached the edge of space. Fact 28. The calm of microgravity. Once a rocket reaches orbit, the feeling inside changes. Weight does not disappear. Instead, weightlessness begins. Astronauts float not because there is no gravity, but because they are falling around Earth at just the right speed, always moving forward fast enough to never touch the ground. This creates microgravity, a quiet drifting state where objects glide slowly, water gathers into shimmering spheres, and motion continues until gently guided by a fingertip. In microgravity, everything is softer. Voices are quieter, movements calmer, breathing deeper. It is as if the body learns a new rhythm, one that matches the slow turning of Earth below. In this floating calm, space begins to feel like a place to rest. Fact 29. How Earth looks from orbit. From orbit, Earth appears round, luminous, and tender. Not the sharp globe of textbooks, but a world wrapped in blues, greens, and swirling white clouds that move like slow, celestial brushstrokes. The continents seem softened, their borders invisible. Nations blending into a single shared landscape. Astronauts often speak of the overview effect, a gentle shift in awareness, a sense of deep connection and quiet responsibility. To see Earth from above is to understand its fragility, a small, glowing oasis suspended in endless night. Cities shimmer like tiny constellations at dusk. Storms curl like giant, silent seashells of cloud, and all of it moves with patient grace. From above, Earth is not divided, it is whole. Fact 30. The thin blue line of atmosphere. One of the most striking sights from orbit is the thin blue line of Earth's atmosphere. It is delicate, only a few hundred kilometers thick, yet it holds every breath ever taken, every cloud that has drifted, every bird that has soared. Seen from space, it glows like a watercolor ribbon, fading from sapphire to pale turquoise to soft white. This layer shields us from harsh radiation, burns incoming meteors to dust, and keeps the planet warm enough for water to flow and life to grow. From a distance, its fragility is unmistakable. It seems almost too thin to hold an entire world of oceans and forests and dreams, and yet it does, delicately, effortlessly, with ancient patience. The atmosphere is the quiet breath of Earth itself. Fact 31. The feeling of floating. In the quiet of orbit, weightlessness becomes a new way of being. Astronauts say that at first, the body resists. Arms drift upward, feet forget where down once was, and every motion sends you gliding slowly through the cabin. But soon, floating feels natural, almost soothing. Movement becomes effortless, like swimming through still air. There is no need to stand or sit. The body simply rests in the position it finds most comfortable. Sleeping is gentle, with no pressure on the back, no mattress beneath you, just a sleeping bag anchored so you don't drift away. In this environment, stress loosens, breathing calms, and the mind learns how soft motion can truly be. To float is to let go of weight and simply be. Fact 32. The silence of space. Outside the spacecraft, space is silent, not quiet in the way a forest is quiet, but silent in a deeper, more profound way. There is no air to carry sound, no wind to rustle, no distant humming to fill the gaps. The engines, once roaring, now rest. The vibrations fade, and the spacecraft travels in a hush so complete that even your heartbeat can feel loud in comparison. Astronauts often describe it as peaceful, a silence that feels ancient, stretching out in all directions. When they look out the window, stars shine steadily, not flickering, not wavering, just glowing in stillness. This silence is not empty. It is full of presence, full of the vastness that surrounds us. In space, quiet becomes a companion. Fact 33. Rockets that carry satellites. Many rockets are launched not to carry people, but to place satellites gently into orbit. These satellites help Earth in quiet ways every day, guiding ships across oceans, helping pilots navigate the sky, allowing us to talk, share, and connect across great distances. Some watch weather patterns unfold, tracing the swirling motion of clouds so we can prepare for storms. Others map forests, oceans, and ice, helping us understand how the planet is changing. From orbit, satellites drift in paths choreographed with great care, moving at thousands of kilometers per hour, yet seeming still against the endless dark. Though we rarely think of them, they are our silent companions, circling above like calm, watchful stars. They remind us that space is not far away. It touches life every day. Fact 34. Watching Earth from far above. Many satellites carry cameras that watch Earth continuously, not to pry, but to understand. They observe cloud formations curling over oceans, mountain shadows stretching across morning landscapes, and the shimmering glow of city lights blooming at dusk. From their orbit, they can see storms forming days before we feel the rain, and can follow the path of rivers as they wind like blue silk through valleys. These images remind us of Earth's gentle beauty, its swirls of white cloud, its patches of deep forest green, its oceans glimmering like polished stone. The planet appears serene from above, even when life below feels busy or heavy. Satellites let us witness Earth with soft wonder, as though we are looking at a beloved place from a quiet, thoughtful distance. They show us home, wrapped in light. Fact 35. The global web of communication. High above us, satellites form a network, a delicate web of signals stretching around the globe. These signals carry voices, messages, songs, weather alerts, navigation data, and stories from one shore to another. Without rockets placing these satellites into orbit, the world would feel much farther apart. A single text message crossing from one continent to another travels first into space, touching the edge of the atmosphere before returning to Earth again. Our conversations ride on invisible waves, flowing softly through the quiet dark of orbit. Because of this web, we can speak across oceans as easily as across rooms. Humanity remains connected, gently, constantly, like a heartbeat. Space has become part of how we talk, share, and understand. Fact 36. Weather eyes in the sky. Weather satellites observe Earth not just to predict storms, but to protect life. They watch hurricanes gather strength far out at sea, giving time for towns to prepare. They track droughts slowly shaping the land and monsoons sweeping across distant islands. From above, weather is not chaotic. It is patterned, rhythmic, like a slow breathing of air and water. Clouds swirl in vast spirals. Thunderstorms bloom like white flowers rising from the equator, and jet streams weave like invisible rivers of wind. These satellites help farmers plant crops, pilots chart safe skies, and communities know when shelter is needed. Their constant gaze is gentle, steady, reassuring. They watch the world with patience, so we may live with understanding. Fact 37. Telescopes. Flown beyond clouds. Many of the most extraordinary telescopes do not sit on mountaintops. They float above Earth, carried there by rockets. In orbit, there is no atmosphere to blur or distort starlight. The stars shine crisp and steady, and distant galaxies appear with clarity impossible from the ground. The Hubble Space Telescope, for example, drifts in silent circles around Earth, its mirrors steady, its sensors open like quiet eyes gazing into infinity. It has shown us blue nebulae shaped like wings, galaxies swirling like gentle seashells, and clusters of stars packed together like diamonds on velvet. From above the clouds, space becomes not distant, but present, a vast and intimate canvas. These telescopes remind us that wonder grows clearer when we rise above the haze. Fact 38. Rockets that carry astronauts. Not all rockets are automated. Some carry people, astronauts who breathe, speak, and dream as they rise toward orbit. Their spacecraft sits near the top of the rocket, a small capsule protected, cushioned, and carefully prepared. Inside, the astronauts are secured gently in their seats, surrounded by screens that glow softly like stars in a quiet room. When the engines ignite, they feel the push of acceleration. Their bodies pressed back with growing force, like sinking slowly into warm sand. They do not see the flame beneath them. They feel its steady intention. As the rocket climbs, the sky fades from blue to indigo, then to the endless depth of space. And within that transition, something quiet occurs inside, a sense of crossing a threshold few have crossed before. The journey is not only physical, it is deeply human. Fact 39. The first human in space. In 1961, a young cosmonaut named Yuri Gagarin became the first human to orbit Earth. He rode atop a rocket called Vostok 1. Its cabin small, its system simple by today's standards, yet strong enough to carry him into the unknown. When he reached orbit, he looked down at Earth and described it as beautiful, a single word spoken softly across history. He saw continents with no borders, oceans with no divisions, clouds drifting like gentle lace across the surface of the world. His flight lasted just 108 minutes, but its impact has lasted throughout generations. In that time, humanity learned that we could leave Earth, not only in stories and dreams, but in reality. And from that moment, the sky was no longer the limit. Fact 40. Gentle greetings from Yuri Gagarin. When Yuri Gagarin returned to Earth, he did not speak of conquest or triumph. He spoke of peace. He greeted the world with a smile that felt familiar, as though he had simply stepped outside and looked back home from the garden gate. His words were calm. I see Earth. It is so beautiful. Not grand, not dramatic, just a quiet truth. That moment softened something in humanity. It showed that leaving Earth does not separate us from it. It deepens our connection. Gagarin became a symbol of shared wonder, a reminder that our planet is delicate and bright, floating in silence. He carried no flag in his heart, only awe. And through his gentle voice, the stars felt a little closer. Fact 41. The race to the moon. After Gagarin's flight, nations looked upward with renewed longing. A quiet challenge formed in the air. Could humans walk on another world? The United States began the Apollo program, a vast effort involving thousands of engineers, scientists, and dreamers. It was called a race, but beneath the headlines, it was truly a journey of curiosity. Mathematics and metal, courage and patience, heart and technology, all woven together toward a single distant goal. The moon became not just a symbol of mystery, but a destination, a place we could reach with steady hands and steady minds. The dream of standing on its quiet surface no longer felt like myth. It felt like a promise waiting in the dark sky. Fact 42. The building of Saturn V. To reach the moon, a rocket of extraordinary power was needed, and so engineers created Saturn V. It stood taller than a 36-story building, shining white against the sky like a pillar of morning light. Yet, despite its size, its design was elegant. 3 stages stacked with purpose, each destined to lift and then fall away, carrying the astronauts higher and higher. When Saturn V launched, the ground trembled for miles. water rippled in nearby rivers, and clouds shook as though stirred by ancient winds. Yet from afar, its ascent looked calm, a slow, steady lift into the waiting sky. Saturn V did not simply fly. It escorted humanity across a threshold, from Earth's embrace to the realm of another world. And with its power, the door to the moon opened. Fact 43. The most powerful rocket ever flown. Saturn V remains to this day one of the most powerful rockets humanity has ever launched. Its engines, 5 enormous F-1 boosters, created a column of fire so vast that it lit the morning sky like a second sunrise. And yet, its power was not chaotic. It was controlled, measured, purposeful. The rocket weighed over 6 million pounds at launch, but in less than 3 minutes, it had risen above the thickest layers of the atmosphere, its first stage spent and falling gently back toward the sea. The astronauts inside did not see the flame beneath them. They simply felt a continuous deep push, as though being carried by a rising tide. Saturn V was not merely machinery. It was the combined work of countless hands and minds devoted to gently lifting humanity toward the stars. It showed what we can achieve when we dream together. Fact 44. Apollo, rising into dawn. Each Apollo mission began before sunrise, the rocket waiting in the cool early twilight, bathed in pale blue light and quiet anticipation. As countdown neared 0, the world seemed to hold its breath. And then, a spark, a flame, a steady blossoming of light. The rocket rose, slow and calm, as though it had always intended to do so. Observers often recall not the noise, but the feeling. A deep vibration in the chest, like standing near a great heartbeat. Inside the capsule, astronauts remained focused, surrounded by soft indicator lights, checklists, steady voices in their headsets. They were both travelers and caretakers, guiding the ship as it carried them away from Earth. In those moments, dawn did not come from the horizon. It rose from the launch pad. The day began with flight. Fact 45. The lunar trajectory arc. Traveling to the moon is not a straight path. The spacecraft follows a curved trajectory, one shaped by gravity, motion, and gentle precision. After reaching orbit around Earth, the upper stage of the rocket fires again, giving the spacecraft the quiet push it needs to slip into a translunar coast. Then, the engines fall silent. The spacecraft drifts, calm, steady, lonely, gliding through the dark with the moon slowly growing larger ahead. This coast lasts for days, not hurried, not rushed, but patient. Astronauts watched Earth shrink to a delicate blue marble, while the moon grew from a coin to a world. The journey felt like crossing a vast ocean, guided not by wind or tide, but by subtle mathematics and unwavering trust. And in that long drifting arc, space became a gentle sea. Fact 46. The command module. A tiny home. When traveling to the moon, astronauts lived inside the command module, a compact cone-shaped room no larger than a small bedroom. It held everything they needed: controls, seats, storage, food, instruments, and small windows through which Earth and the moon drifted past. The walls were wrapped in switches and dials, each one quietly waiting to be touched. There was no space to walk, only space to float, gently pushing from one side to the other with a fingertip. Life inside was simple and calm. Meals came in small pouches. Sleeping happened inside softly secured bags, and conversation unfolded like quiet murmurs in the dark. The command module was not luxurious, but it was enough. It was a home carried through a sea of stars. Small spaces can hold great journeys. Fact 47. The service module, a silent guardian. Attached to the command module was the service module, a larger cylinder containing fuel, oxygen, power systems, and engines. It did not carry people. Instead, it carried support. It was like a beating heart that worked quietly in the background, circulating energy, warmth, and life. The astronauts rarely interacted with it directly, yet their safety depended on its steady, reliable functioning. Inside were tanks filled with precious air, radiators that released heat into space, and guidance systems that kept the ship on course. The service module asked for nothing, made no sound in the vacuum of space, and left no signature except its unwavering presence. When the crew returned home, the service module was released, its duty complete. It fell into the atmosphere and burned away, like a guardian who steps back into the night. Not all protectors are seen. Fact 48. The lunar module, a soft landing dream. To land on the moon, astronauts transferred into the lunar module, a delicate, insect-like craft designed for gentle descent. Its walls were thin, so thin you could almost press a hand through them. But every layer was chosen with care, balanced perfectly between strength and lightness. There was no need for aerodynamics here. The moon has no air. The lunar module flew not with wings, but with calm, measured bursts of thrust. Its legs unfolded like the limbs of a heron settling beside quiet water. When it touched the moon, it did so with softness, a gentle kiss between machine and dust. Inside, the astronauts felt the hush of another world, a silence older than humanity itself. This was not just arrival, it was communion. Fact 49. Footprints on quiet dust. When the lunar module settled onto the moon, the surface beneath it was soft, powdery, and untouched by wind or rain. The moon has no atmosphere to smooth or change it, so every footprint pressed into that dust remains, undisturbed even after decades. When astronauts stepped down the ladder, their movements were slow and gentle, floating lightly in a 1/6 of Earth's gravity. They walked, not with heavy steps, but with an easy, bounding rhythm, as if moving inside a dream. The dust clung to their boots like fine charcoal, marking their presence on a world that had waited silently for billions of years. No breeze came to erase it. No sound echoed. Only the soft imprint of human curiosity remained, a quiet signature of our first steps beyond home. Fact 50. Returning safely through fire. Leaving the moon was only half the journey. To come home, astronauts rode the command module back toward Earth at tremendous speed. As the spacecraft re-entered the atmosphere, the air in front of it compressed so fiercely that it heated into a curtain of glowing plasma, a shell of fire surrounding the ship. But the module carried a heat shield, a layer designed to slowly burn away, carrying heat with it. Inside, the astronauts felt only gentle shaking, listening to the crackling hiss of ionized air outside. In that moment, they traveled between worlds, from the silence of space back into the warm breath of Earth's sky. Re-entry is not a fight, but a return to an embrace. Through fire, the journey comes home. Fact 51. The space shuttle's gentle wings. After the Apollo missions, a new spacecraft was created, one that could be flown again and again. The space shuttle looked like a white glider carried to orbit by a pair of solid boosters and a large orange tank. Where earlier spacecraft fell to Earth, the shuttle landed, gliding through the atmosphere on wide, soft wings. It carried astronauts, satellites, experiments, and even pieces of what would become the International Space Station. Inside, it felt more like a small home than a capsule, with room to float, to work, to live. The shuttle made space feel a little closer, a little more familiar, as though the journey there was not an exceptional event, but something humanity could now do routinely. It was a ship designed not just for travel, but for returning, learning, and trying again. It marked the beginning of reusable dreams. Fact 52. Reusable dreams. Begin. The space shuttle represented a new idea in spaceflight, that a spacecraft could return, be repaired, and fly again. This was a shift from single-use rockets, which fell away after their mission and were lost to sea or sky. The shuttle glided back to Earth like a silent white bird, touching down on long runways under open sky. Its tiles, though fragile, protected it from the fire of re-entry. Its engines, carefully inspected, could be awakened once more. This idea of reusability planted a quiet seed in the imagination of engineers. What if rockets could return too? What if space travel could become as familiar as flight? The shuttle was not the final answer, but it was the first true step toward a gentler, more sustainable way of reaching the stars. It taught us that the journey does not end when we come home. Fact 53. Riding on twin solid sparks. To rise from the launch pad, the shuttle relied on two solid rocket boosters attached to its sides, powerful cylinders filled with solid fuel. When ignited, they burned steadily, their flames bright and fierce, producing a raw, thunderous thrust. Unlike liquid engines, solid boosters cannot be throttled or turned off. They burn until their fuel is gone. This required careful timing, careful planning, and deep trust in design. As the shuttle climbed, the boosters roared like twin comets, their plumes tracing bright white paths through the morning sky. 2 minutes into flight, when their work was done, they separated with a gentle push and drifted earthward under wide parachutes, where ships waited to recover them. Even these powerful engines were built to be reused, a small but steady step toward the future. Each flame left a lesson behind. Fact 54. The shuttle's cargo bay of wonders. Inside the shuttle's long cargo bay, scientists placed instruments, satellites, and experiments destined to expand human understanding. The bay was like a quiet workshop carried into space, a place where telescopes could be repaired, where new satellites could be released, where pieces of space stations could be carried up, one gentle journey at a time. Astronauts would open the bay doors in orbit, revealing not emptiness, but the soft glow of Earth drifting below. The robotic arm inside, the Canadarm, moved slowly, gracefully, as if it understood the stillness around it. With care, it lifted satellites, supported spacewalkers, and assembled structures that would remain in orbit for decades. The cargo bay was not just storage. It was a cradle for ideas, a place where imagination took physical form. From this quiet space, wonders unfolded. Fact 55. Building the International Space Station. The International Space Station, or ISS, was not launched all at once. It was built piece by piece, carried into orbit by dozens of space shuttle missions and other rockets from around the world. Each module was gently guided into place, connected like careful puzzle pieces drifting in microgravity. The station slowly grew into a home, a long silver and white structure floating 400 kilometers above Earth, circling the planet every 90 minutes. Astronauts inside look out at oceans, mountains, and deserts passing quietly beneath them. Sunrise followed by sunset, again and again, 16 times every day. The ISS is not just machinery. It is a symbol, a place built through cooperation, patience, and shared hope. It showed that nations can come together to explore, gently and peacefully. Fact 56. The long construction in orbit. Constructing the ISS in space was unlike building anything on Earth. There was no up or down, no scaffolding, no cranes, only careful movement, floating tools, and gloved hands guided by steady breath and slow thought. Astronauts would step outside the airlock, tethered only by thin lines, their bodies drifting in the endless dark. They worked slowly, fastening trusses, cables, and solar panels with precision that felt almost meditative. Each piece had to align perfectly, like a quiet harmony between humans and machine. The station grew not in haste, but in a calm, continuous unfolding, a structure assembled in the soft silence of space. And day by day, it became a home where people from many countries could live and learn together. It was built in stillness, but born from connection. Fact 57. Living among the stars for months. When astronauts live on the ISS, their lives follow a gentle rhythm. They float through modules that serve as kitchen, workspace, gym, and bedroom, anchoring themselves with toes, fingers, or quiet handholds on the walls. They wake to the soft hum of ventilation systems, a sound that becomes comforting, the heartbeat of the station. Meals are shared in drifting circles, spoons held carefully so nothing floats away. Exercise keeps muscles strong, since weightlessness can cause them to weaken. Astronauts look out the window often, not out of longing, but out of appreciation. They see auroras shimmer like green rivers, cities glowing like constellations, lightning storms flashing like silent fireworks far below. Life in orbit is simple, even peaceful, a reminder that home can be wherever we carry our breath and our wonder. Among the stars, humanity learns to live gently. Fact 58. Supply ships visiting quietly. Even though the International Space Station circles Earth far above the clouds, it is never truly alone. Uncrewed supply ships arrive regularly, carrying food, clothes, scientific instruments, and letters from home. These ships come from different nations, each with its own gentle design and purpose. Some dock automatically, moving with patient precision, guided by sensors and quiet calculations. Others require astronauts to reach out with the robotic arm, capturing the supply craft slowly and gracefully, like catching a drifting feather in still air. There is no rush, only timing, breathing, and trust. When the hatch finally opens, the station welcomes its visitor like a friend at the door. Fresh fruit, new tools, and even small surprises remind the crew that Earth has not forgotten them. In this way, the station stays connected to home, softly and continuously. Fact 59. Soyuz, the reliable companion. For many years, astronauts traveled to and from the ISS in a spacecraft called Soyuz, a design refined with care over decades. Soyuz is compact, dependable, and shaped like a gentle teardrop that returns safely through Earth's atmosphere. Before launch, it rests atop its rocket like a seed waiting to rise. Inside, astronauts are snug in their seats, surrounded by simple, sturdy instruments that have served generations of spacefarers. Soyuz does not boast of speed or size. Its strength lies in reliability. It has carried explorers from many countries, guided not by competition, but by shared purpose. Its descent back to Earth ends under large blossoming parachutes, drifting down to the quiet grasslands of Kazakhstan. As the capsule lands, dust rises softly into the air, and the journey closes with a sound of wind instead of roar. Soyuz is a reminder that trust, refined slowly, can last across eras. Fact 60. The grace of orbital docking. Docking, two spacecraft in orbit, is a delicate ballet. Both vehicles move at thousands of kilometers per hour. Yet to connect, they must approach each other with the softness of a feather touching still water. Tiny thrusters puff in short, controlled bursts, adjusting alignment by mere centimeters and fractions of a degree. Astronauts watch carefully through small windows, gauging motion in the vastness of space. There is no noise when the two spacecraft meet, only a gentle click, a latch closing, a seal forming between worlds. Then the hatches open, and one spacecraft becomes part of another, their hearts and systems linked. Docking is cooperation made visible, a quiet joining in the silence of orbit. It is how journeys continue, without hurry, without force. Fact 61. SpaceX and new reusability. A new chapter in rocketry began when SpaceX introduced the idea of rockets that could return and fly again. This meant treating rockets not as one-time sparks of flame, but as vehicles designed to learn, land, and rise once more. The Falcon 9 rocket was built with legs that fold out like quiet silver branches, waiting to touch the ground again. Its engines are programmed with gentleness and restraint, guiding the rocket back through the atmosphere with careful bursts of flame and small steering adjustments. The first successful landing did not come easily. Attempts ended in soft explosions and broken pieces, but engineers persisted with patience, curiosity, and hope. Then one day, the rocket descended slowly, stood upright, and settled onto its landing pad like a tall flame extinguishing into stillness. It marked a shift from throwing rockets away to bringing them home. A promise that spaceflight could become sustainable, even graceful. Fact 62. The first Falcon's return. The moment the first Falcon 9 booster returned to Earth was met not with cheering noise, but with quiet awe. People watching held their breath as the booster lowered itself through the air, flame flickering softly beneath it like a candle guiding its own descent. It did not fall. It arrived gently, precisely, as though gravity and flame were in conversation. For decades, rockets had vanished into the ocean or burned in the sky. But now one stood again, soot-blackened and silent, telling a story of persistence and patience. Engineers touched the metal like archaeologists uncovering a long-hidden relic. It was not just a returned rocket. It was a symbol that the future might be closer than we once believed. Reusability had moved from dream to reality, softly and steadily. Fact 63. Landing on a ship at SpaceX did not stop with landing on land. They set their sights on something even more delicate, landing a rocket on a ship floating in the ocean. The ship is broad and calm, painted with the gentle phrase, "Of course, I still love you." Upon its deck, a landing circle waits. The ocean shifts. Waves lift and lower the platform. Wind moves across the water in slow breaths. And yet the rocket descends, guided by computers that read motion like whispering tides. With a final soft touch, its legs settle onto the moving deck, balanced between sky and sea. There is no roar in this moment, only the quiet, astonishing beauty of precision. A rocket standing again, where ocean meets horizon. Fact 64. Rockets that fly, again and again. Once a rocket can return home, it is no longer a single moment of fire and departure, but a traveler, capable of making many journeys. Falcon 9. Boosters are cleaned, inspected, and prepared for another flight. Scorch marks remain along their sides, dark streaks like stories written in smoke, reminders of where they have been. Their engines are tested gently, their structures checked with patient care. And when they rise again, They carry not just payloads, but history. Each flight teaches engineers something new: how to refine landing legs, how to guide descent with greater precision, how to extend the life of a machine meant for the edge of space. Reused rockets are like seasoned travelers, quiet, steady, and familiar with the path. They transform spaceflight from event to practice. Fact 65. Starship and its silver skin. SpaceX's next step is Starship, a towering spacecraft made of shining stainless steel, reflecting the world around it like a calm lake mirrors the sky. Its surface gleams beneath sunlight, moonlight, and the warm glow of launch tower lights. Starship is designed to carry people, cargo, and dreams to the moon, Mars, and perhaps beyond. Despite its size, its exterior feels surprisingly smooth and simple. No paint, no ornate markings, just silver curves shaped for the sky. Inside, the design imagines room to move, to sleep, to gather, to look out large windows and watch planets rise. Starship is not only a vehicle, it is an idea. That space may one day be traveled not by a few, but by many. It glimmers with the promise of tomorrow. Fact 66. Building for other worlds. For the first time in history, rockets are being designed not only to leave Earth, but to land and live on other worlds. Starship aims to settle gently onto the surface of the Moon or Mars, engines whispering dust into soft clouds beneath it. Once there, it could serve as shelter, laboratory, and home. Life in other places will be different, bounded by new gravity, new landscapes, and new rhythms of light. But humans have always adapted, carrying their warmth, their stories, and their quiet resilience with them. Rockets are no longer simply escape vehicles. They are bridges to new horizons. The journey outward is not about leaving Earth behind, but extending its spirit into the stars. To explore is to gently unfold the boundaries of home. Fact 67. Blue origin and suborbital journeys. Not all rocket flights are meant to reach orbit. Some are designed to rise gently above the atmosphere, touch the edge of space, and return. A brief, quiet visit to the stars. Blue Origin's New Shepard rocket does exactly this. It carries passengers upward in a smooth arc, where the sky fades to black and Earth curves softly below. For a few precious minutes, travelers float in microgravity, drifting in silence and wonder, watching the world turn beneath their fingertips. Then, the capsule returns on parachutes, descending like a falling seed settling back into Earth's open hands. These suborbital journeys remind us that space is not distant. It begins just above the reach of clouds. Even short flights can awaken long dreams. Fact 68. Virgin Galactic's air-launched path. Another way to reach space begins not from the ground, but from the sky. Virgin Galactic uses a carrier aircraft to lift a small spacecraft high into the atmosphere before releasing it to ignite its rocket engine. This method feels gentle, like passing a torch between friends. The spacecraft climbs smoothly, its wings folding and unfolding to guide its path. Inside, passengers float in wide, open cabin space, able to turn, laugh, breathe, and look through large windows at the blue arc of Earth glowing below. There is no rush, only drifting, a slow awareness of being between worlds. When it returns, the wings shift into a special feathered configuration, allowing a soft glide back to the runway. This is spaceflight shaped like a sigh, calm, graceful, unhurried. Fact 69. Private astronauts and gentle tourism. For much of history, space was a place only a few trained explorers could travel. But now, quietly and gradually, the possibility is opening for others: scientists, teachers, artists, dreamers. Private astronauts are beginning to visit space not for conquest, but for experience. They travel in capsules designed for comfort, with wide windows and smooth interior curves, so that the most important view, Earth, fills the senses completely. When they return, they often speak not about excitement, but about perspective. How fragile the atmosphere looked, how silent the world seemed, how borders disappeared in the soft glow of dawn. Space tourism is not about thrill, it is about awe. It is about remembering that we live on a small, shared home, floating through the quiet, and awe, gently felt, changes us. Fact 70. Rockets for robotic explorers. Not all rockets carry humans. Many carry robotic explorers, carefully built to withstand distant worlds where people cannot yet go. These explorers travel to Mars, Venus, the asteroid belt, and even beyond the orbit of the outer planets. Inside them are cameras, sensors, drills, and quiet computer minds ready to listen to the whispers of new landscapes. They land on dusty plains, icy moons, and ancient craters, recording everything gently: temperature, dust, minerals, sunlight. Their messages travel across millions of kilometers, moving at the speed of light, arriving back on Earth like postcards from faraway shores. Each robotic explorer extends our senses, carrying our curiosity like a soft flame into the dark. Through them, we see the universe before we step into it. Fact 71. Sending rovers to other suns. Rockets have delivered rovers to worlds we have never touched, most famously Mars. These rovers move slowly, not because they lack power, but because they explore with patience. Each wheel turn is measured, each movement deliberate, to avoid slipping on sandy slopes or sharp rocks. Their robotic arms reach out like gentle hands, studying stones that have not been touched in billions of years. Some rovers carry microphones, letting us hear another world, the soft whisper of wind across red plains. Others carry tiny laboratories, searching for clues of past rivers and ancient microbial life. Rovers are travelers with no hurry, learning by being still, by watching light fall across alien horizons. They are the slow walkers of distant worlds. Fact 72. The long travel to Mars. Traveling to Mars is not a quick journey. Even with powerful rockets, the trip takes months. A long drifting arc through space, where the sun glows steady and stars remain unchanging. During this voyage, astronauts would live inside a spacecraft that becomes their world, sleeping, working, exercising, watching Earth shrink and Mars grow. Meals are simple, conversations calm, and time passes softly, measured by the hum of machinery and the quiet rhythm of human presence. Outside the windows is a silence deeper than any experienced on Earth, a silence that stretches in all directions. The journey to Mars is not a race. It is a pilgrimage, carried by patience, trust, and quiet courage. Long travel teaches that distance is just another kind of stillness. Fact 73. The tiny thrusters that make fine adjustments. Large engines launch rockets from Earth, but once in space, movement becomes a softer art. Spacecraft use tiny thrusters, no larger than small nozzles, to rotate, drift, and align themselves. These thrusters release faint puffs of gas, bursts so gentle they would barely disturb a candle flame, yet in the emptiness of space, they are powerful enough to turn entire ships. Astronauts describe the sensation as almost dreamlike, a slow tilt, a quiet glide, as though the spacecraft is a leaf floating on still water. There is no sound when they fire, only motion, no roar, no shake, only a shift so calm that it feels like thought translated into movement. In space, even the smallest breath of motion can carry you far. Fact 74. Ion engines and electric breeze. Some spacecraft do not burn fuel in roaring flames at all. Instead, they use ion engines, which work by accelerating charged particles and releasing them as a steady, gentle stream. The push they create is incredibly soft, like the weight of a sheet of paper resting in your hand. But this soft push never stops. Day after day, week after week, the spacecraft accelerates, gaining speed slowly, steadily, until it travels faster than any rocket-powered craft could. Ion engines glow with a faint blue light, quiet and beautiful, like a candle burning underwater. They are engines of patience, designed for journeys measured not in days, but in years. They remind us that gentle effort, continued faithfully, can cross great distances. Fact 75. Solar sails and light as a guide. There's another way to travel through space, by using light itself. Solar sails are wide, reflective sheets that unfurl like silver wings. Photons, tiny packets of sunlight, press against the sail as they travel from the sun. The push is delicate, far softer than a whisper on skin. But in the vastness of space, even this touch can move a ship. The sail does not burn fuel, and it makes no sound. It simply drifts, guided by the steady glow of starlight, accelerating slowly toward distant worlds. Sailing through space is not like sailing through wind. It is like gliding through time, carried by radiance. These sails teach us that motion can be born from light, and that sometimes the universe carries us gently forward. Fact 76. Guidance. Computers with quiet precision. Every rocket and spacecraft is guided not only by engines, but by computers that calculate position, speed, and direction with calm and steady accuracy. These computers read information from sensors, gyroscopes, star trackers, and radio signals, building a quiet map of where the spacecraft is and where it needs to go. The guidance computer does not shout its commands. It adjusts motion softly, with tiny pulses of thrusters or gentle shifts in engine power. Even during the intense moments of launch, its logic remains composed, like a steady hand on a tiller steering through waves. In deep space, where no landmarks exist, it sometimes navigates by stars, recognizing constellations the way sailors once did on open oceans. It is the quiet mind behind every journey. Fact 77. Star trackers and celestial navigation. To know where it is, a spacecraft may look outward, measuring the positions of stars against the darkness. These instruments are called star trackers, small optical sensors that take pictures of the sky and compare the pattern of points to an internal star map. Even in the cold vacuum, stars shine with steady clarity. They do not twinkle as they do from Earth, because there is no atmosphere to blur their light. The spacecraft reads these patterns and understands its orientation, just as ancient navigators once lifted their eyes to the constellations to steer across the sea. In this way, space travel carries a memory of humanity's oldest journeys, the quiet reliance on stars. No matter how advanced the technology becomes, the sky remains our guide. We travel through space the same way we once crossed oceans, by starlight. Fact 78. Communications. Across the silent distance, rockets and spacecraft speak with Earth through long, invisible threads of radio waves. These signals travel across empty space, carrying data, voice, and gentle tones of telemetry. Because space is silent, these signals move without distortion, clean and clear, though they grow fainter with distance. When a spacecraft is near Earth, Messages arrive almost instantly, but when it is far, perhaps orbiting Mars or beyond, there is a delay. Sometimes a question must wait minutes before its answer returns. This teaches patience and deepens appreciation for connection. Even across millions of kilometers, a spacecraft can whisper its status, its heartbeat, its position among the stars. Distance does not end communication. It simply slows the conversation to a thoughtful pace. Fact 79. Deep Space Network listening patiently. To hear spacecraft across the vast distances of the solar system, Earth relies on something called the Deep Space Network, a collection of enormous radio antennas spread across 3 quiet locations: California, Spain, and Australia. Their placement allows Earth to listen no matter how the planet turns, ensuring that distant explorers are never out of reach. These antennas are wide, white dishes that tilt slowly across the sky, tracking faint signals like a person turning their head to hear a soft voice. The messages they receive are delicate. Sometimes, only a whisper of data carried across billions of kilometers. Yet with patience and understanding, those faint signals are translated into images, measurements, and gentle updates from worlds far beyond. The Deep Space Network is the ear with which Earth listens to the cosmos. Fact 80. The feeling of a launch day. For astronauts preparing to fly, launch day begins quietly. They wake early, eat a simple meal, and slip into their suits with the help of calm, practiced hands. The walk to the rocket is slow and intentional, like approaching the threshold of a dream. Outside, the rocket waits, standing tall against the morning sky, faint vapor drifting around it like pale mist. Inside the spacecraft, astronauts buckle in, checking systems with soft voices, their breathing steady. As countdown nears 0, the world becomes very still. Then a gentle vibration begins, a rumble, a rising pulse. The rocket does not leap upward, it lifts, pressing them softly into their seats as the sky opens. Launch is not only force, it is surrender to upward motion. It is the moment when Earth lets go, just for a little while. Fact 81. Looking back at the blue marble. Once a spacecraft ascends far enough above Earth, the planet appears whole, round, shining, and quietly alive. This is the blue marble view, famous not for grandeur, but for simplicity. From space, there are no borders, no divisions, no harsh lines, only swirling clouds, soft oceans, and continents shaped by time. Astronauts often describe a feeling of tenderness, as though seeing Earth from distance makes one love it more deeply. They realize how thin the atmosphere is, how delicate the water cycles are, how small and shared our living world truly is. This view is not loud or overwhelming. It is gentle, a reminder that life is rare, precious, and quietly beautiful. To look back at Earth is to remember where we belong. Fact 82. The fragile atmosphere. Seen from above. From space, Earth's atmosphere appears as a thin, delicate veil, a narrow band of pale blue wrapped around a world of land and water. It is astonishing how slender it seems, a glowing ribbon only a few breaths thick compared to the size of the planet it protects. Within that thin layer is everything we depend on. Every breeze, every cloud, every drop of rain, every bird that has ever flown, and every word that has ever been spoken aloud. Astronauts say that seeing the atmosphere from above fills them with a sense of quiet gratitude. They realize how easily it could be harmed and how gently it must be cared for. The atmosphere is not a barrier. It is a gift, soft as silk, ancient as oceans, and necessary as breath. To see it is to understand its fragility. Fact 83. Spacewalks in the silent dark. When astronauts step outside a spacecraft, they enter an environment unlike anything on Earth. A spacewalk is a slow dance in absolute silence. There is no wind, no sound, except the soft hiss of the suit's life support system and the steady rhythm of one's own breathing. The astronaut is tethered, connected by a thin lifeline to the station or ship, floating gently above the planet. Work in space is done with patience. Gloved hands tighten bolts, move tools, guide equipment with movements that must be steady and intentional. Every action is calm, controlled, deliberate. Earth turns silently below, a moving masterpiece of blue, brown, white, and green. Sunlight is bright and direct, and the shadows are deep and absolute. A spacewalk is not loud heroism. It is mindfulness made physical. It is a moment of being fully present, between worlds. Fact 84. The suit that becomes a personal world. During a spacewalk, the spacesuit is a tiny spacecraft of its own. It provides air to breathe, temperature to live in, and gentle pressure to keep the body safe. The suit has no softness to its shape. It is sturdy, layered, protective, shielding the wearer from vacuum and radiation. Inside, the astronaut moves slowly, feeling the gentle resistance of the suit with every motion. A visor shields the eyes from harsh sunlight, while heaters and circulation systems maintain warmth. The suit listens to the wearer's breath, monitors heartbeat and humidity, and keeps careful watch over safety. It is both armor and cradle, not heavy in microgravity, but reassuring in presence. When worn, it becomes an entire world one can carry. It lets a human walk in a place where life cannot exist on its own. Fact 85. The beauty of sunrises in orbit. Astronauts aboard the ISS witness sunrise not once a day, but 16 times as the station circles Earth at great speed. Each sunrise is brief and gentle, a slow bloom of gold along Earth's curved horizon. First, the sky glows deep sapphire, then shifts to rose, amber, and pale pearl. Clouds gleam like soft cotton lit from within. There is no sound to accompany it, only the steady hum of life support systems and the quiet presence of those watching. Sunrise in orbit is not a beginning of a day, but a repeating reminder of rhythm, of cycles, of the world turning with composed, endless grace. To watch the sun rise from space is to feel that time is not rushed, but unfolding like breath. Light becomes a gentle teacher. Fact 86. The blanket of city lights at night. When the station drifts into Earth's shadow, night spreads softly across the planet. From above, city lights form constellations of their own, patterns of gold and silver outlined against the dark. Highways glow like rivers of warmth. Neighborhoods form clusters of quiet luminance, and coastlines shimmer like delicate necklaces. There is no sound in this view, no movement visible, just human presence, glimmering faintly like fireflies resting on a great field. Astronauts often feel a strange tenderness then, recognizing how small our civilizations are and how connected we remain, even in distance. Many say that from space, night is the most peaceful time, a moment when Earth feels like a shared home, softly glowing in the dark. Humanity appears gentle from far away. Fact 87. The whisper of air. Recycling systems inside a spacecraft or station, every breath matters. The air is recycled constantly, filtered and refreshed through quiet systems that work without pause. Carbon dioxide is removed, oxygen is replenished, humidity is balanced carefully. These machines do not roar. They hum, softly and steadily, like distant waves on a quiet shore. Astronauts often come to know the sound intimately as one recognizes the heartbeat of a familiar home. Air must be watched with attention. Monitors display levels. Adjustments are made with care. In space, the atmosphere is not a gift from the world. It is something created and protected moment by moment. This makes each breath feel precious, each exhale meaningful. Life in space teaches awareness. That survival is something maintained through gentle, constant tending. Fact 88. Growing plants in microgravity. On the International Space Station, astronauts tend to small gardens floating in orbit. In a place with no up or down, plants must learn new ways to grow. Their roots are guided by gentle airflow and careful lighting, while their leaves stretch towards soft panels of artificial sunlight. Watching a seed sprout in space is watching life adapt with quiet determination. Astronauts water plants with droplets that cling and wander, gathering on leaves like tiny crystal beads. They observe each stem and flower closely, not just for science, but for companionship. A growing plant brings the reminder of Earth's scent, Earth's patience, Earth's touch. When a flower blooms in space, it is a small miracle, a whisper of home in the deep silence. Life, even far from Earth, finds a way to unfurl. Fact 89. The taste of food. Among the stars, food in space is simple, sealed in pouches and warmed carefully, yet eaten with appreciation that feels deeper than taste alone. In microgravity, flavors behave differently. The sense of smell changes, so astronauts often prefer stronger, richer seasonings. A spoonful must be handled gently, lest it drift away like a small planet escaping orbit. Meals are shared, faces gathered around the small galley, floating together in a quiet circle. There are no tables, no chairs, just people, held in place by handrails, conversation, and presence. Laughter sounds different, bouncing softly between walls. Even something familiar, a bite of fruit, a sip of warm drink, can feel new when experienced with Earth turning below. In space, food is not rushed. It is nourishment, memory, and comfort. Meals become a gentle reminder of our shared humanity. Fact 90. Sleeping while floating. To sleep in space is to surrender completely to weightlessness. Astronauts slip into sleeping bags attached to walls or ceilings, though in microgravity, such directions no longer matter. There is no mattress beneath them, no pillow to press against. The body simply rests, suspended as though floating in a quiet dream of water and air. The hum of life support systems becomes the lullaby of orbit, steady, familiar, rhythmic. Outside the window, sunrise and sunset pass many times each night, but the cabin stays dim, lights low and warm. The sensation of floating does not disturb. It relaxes. Muscles release tension. The spine stretches softly. The body drifts into sleep like a feather settling in still air. To sleep in space is to remember how to rest without weight, without hurry, without the pull of the world. It is rest in its purest form. Fact 91. The quiet practice of daily maintenance. Life on a spacecraft is calm, but it is also guided by routine. Astronauts spend part of each day gently checking equipment, cleaning surfaces, and ensuring every system remains healthy and balanced. In space, even small particles of dust need attention, for there is no gravity to let them settle. Filters are replaced, monitors are observed, and each switch is treated with care. This work is not frantic. It is slow, mindful, almost meditative. The station becomes not only a workplace, but a shared home. Every astronaut contributes to its well-being, like tending to a floating garden of air and metal. Maintenance is an act of respect for the habitat that protects them and for the journey they are part of. Care becomes a form of quiet gratitude. Fact 92. The window that opens to the world. On the International Space Station, there is a window unlike any other. The cupola, a dome of clear panes that looks out over Earth. Astronauts gather here often, floating gently as they press their hands to railings and watch continents drift beneath them. Cloud shadows stretch across deserts. Storms spiral like slow galaxies, and oceans shimmer with shifting silver hues. Some astronauts play soft music in the cupola, letting the view and melody blend into a moment of complete stillness. Many say it is the place where time feels different, where thoughts soften, and the mind opens like a tide pool in gentle light. Looking through the cupola, one sees Earth not as distant or abstract, but as a living presence, turning in silence. It is a window, not just to the world, but to perspective. Fact 93. The emotion of returning to Earth. After months in orbit, returning to Earth can feel like waking from a long, drifting dream. The capsule descends through clouds, parachutes billowing like soft blossoms overhead. When astronauts step out again, gravity greets them, warm and familiar, yet surprisingly heavy. Legs must remember how to walk, and feet rediscover the feeling of ground. The air smells different, rich, full, textured, with the scent of soil, leaves, and open wind. Some astronauts feel overwhelmed with emotion at the simple act of standing among trees or hearing birdsong. The planet they once saw from afar is now intimate again. Returning to Earth is not an end, but a deep exhale, a gentle reunion. Home feels softer when seen from the stars. Fact 94. The sound of a rocket in the distance. When a rocket launches, observers often describe something unexpected. The sound comes after the sight. From a distance, the rocket rises, silently at first, a bright flame lifting slowly into the sky. Only seconds later does the sound arrive, a deep, rolling thunder that feels more like vibration than noise. It resonates in the chest, a low, ancient rumble like mountains shifting or ocean surf collapsing in slow waves. The sound is powerful, yes, but not aggressive. It carries the weight of purpose, a steady push upward. And then gradually, the roar fades as the rocket climbs into thinner air. Soon, there's only the whisper of wind and the memory of what just rose. Launch is seen, then felt, then remembered. Fact 95. The careful counting of fuel. Every drop of rocket fuel matters. The amount is calculated with exquisite attention. Not too little, not too much, but precisely enough for the journey required. Engineers study temperature, pressure, and fuel density, knowing that even a subtle variation can shift the path of the rocket by kilometers. Fuel tanks are insulated and monitored, their levels measured not by floating gauges, but by delicate sensors and mathematical certainty. During launch, fuel flows like a river made of fire, feeding engines that burn hotter than molten metal. Yet the process is controlled, calm, deliberate. The rocket drinks its fuel in measured breaths, each second planned, each moment understood. When stages separate, it is with clean precision, a letting go of what is no longer needed. Spaceflight is not only power, it is balance. Fact 196. The way rockets help us understand ourselves. Rockets may seem like tools of exploration, machines built for distance and discovery, but they are also mirrors. They reflect the quiet truth that humans are drawn to the unknown, to the horizon we have not yet touched. Each rocket launch is a gesture of curiosity, a reaching towards something we cannot yet fully grasp. We build these vehicles with patience and wonder, guided by questions rather than certainty. And when they rise, they carry not only instruments, but hopes. Hopes for understanding, for connection, for meaning. Looking up at a rocket streaking into the sky, we are reminded of our ability to imagine what does not yet exist and to gently, steadily make it real. Spaceflight is a quiet expression of our shared longing to learn. Fact 97. Rockets as bridges between worlds. A rocket is more than metal, engines, and flame. It is a bridge, a connection between Earth and the places beyond our reach. When a rocket leaves the launch pad, it carries with it not only equipment and mission plans, but the intentions of thousands of people who dreamed, designed, calculated, and cared. Rockets transform separation into possibility. They allow us to send messages to distant moons, to touch the surfaces of planets we cannot yet stand upon, to place telescopes where starlight arrives pure and unbroken. Even when they return home burned and worn, their work continues. Stories shared, knowledge gained, paths opened. A rocket is a reminder. That distance is not a wall, but a space we can learn to cross. They turn the sky from boundary into invitation. Fact 98. The gentle science of trajectory. To send a spacecraft anywhere in the solar system, it must follow a trajectory, a path shaped not by force alone, but by understanding the quiet pull of gravity. Planets tug on spacecraft like gentle hands, guiding, redirecting, nudging their course. Sometimes a spacecraft will swing around a planet to gain speed, borrowing momentum the way a dancer borrows motion from a partner's turning step. This is called a gravity assist, and it requires patience, timing, and deep respect for celestial harmony. The calculations are intricate, but the result is graceful, a smooth arc through the void, as though the spacecraft were gliding along a river of invisible currents. In space, travel is not forceful. It is listening, aligning, finding the gentle path through cosmic tides. Trajectory is the art of moving with the universe, not against it. Fact 99. The unbroken thread of human curiosity. From ancient stargazers who traced constellations in the night sky, to modern engineers who send robotic explorers to distant planets, there is a single unbroken thread: curiosity. It lives in quiet questions asked at kitchen tables, in children pointing upward with wonder, in the soft silence of observatories where scientists watch starlight unfold. Rockets did not emerge suddenly. They grew from generations of dreaming. Every launch is a continuation of a thought that began long before any engines roared, a thought that whispered, "What lies beyond this horizon?" Curiosity is not loud. It does not rush. It moves slowly, gently, like a tide rising over centuries. Rockets are simply one expression of that enduring desire to learn, to reach, to understand. We explore because we are human, and because wonder is our oldest companion. Fact 100. The future, waiting quietly among the stars. The future of rockets is not loud or hurried. It unfolds slowly, like dawn across a distant horizon. New engines are being designed to burn cleaner. New spacecraft shaped to carry more travelers. New habitats imagined for moons and planets where footsteps have not yet fallen. Perhaps one day, rockets will take families, artists, gardeners, storytellers, people traveling not to conquer the unknown, but to live gently with it. Maybe cities will glow softly beneath alien skies, and children will look up at Earth the way we look at the moon now. The stars wait without impatience. They do not rush us. They simply shine. And as long as we continue to look upward with quiet curiosity and open hearts, the journey will continue. One launch, one question, one dream at a time. The universe is not far away. It begins the moment we lift our gaze. And as our journey comes to a gentle close, I hope you found a moment of calm among the stars tonight. A chance to breathe a little deeper, to soften your thoughts, and to rest in the quiet wonder of the universe. If you enjoyed drifting through these sleepy facts, feel free to like the video, subscribe, and share which topic you'd love to fall asleep to next. Your curiosity keeps this journey moving forward. Whenever you're ready, you can continue dreaming. Just tap the next Sleepy Astronaut video on your screen and keep floating softly through the cosmos. Sweet dreams, and I'll see you among the stars.